In the vast expanse of the cosmos, humanity's insatiable curiosity has driven us to explore beyond the boundaries of our own planet. But what if we could do more than just visit alien worlds? What if we could transform them into habitable environments suitable for human colonization? Welcome to Terraforming, transforming alien worlds into habitats. Before we delve into the intricate details of terraforming, let's first understand what this concept truly entails. Terraforming is the process of transforming inhospitable alien worlds into habitable environments suitable for human life. Imagine barren landscapes, devoid of breathable air, extreme temperatures, and toxic atmospheres. These are the challenges we face when contemplating the colonization of alien planets. But terraforming offers a glimmer of hope, a way to reshape these alien worlds to make them more hospitable and suitable for human habitation. The benefits of terraforming are immense. By transforming these inhospitable worlds, we can expand our reach as a species, colonize new territories, and unlock precious resources that lie dormant in these untapped frontiers. Terraforming offers a pathway to a future where humanity can thrive beyond the confines of Earth. Consider Mars, a planet that has long captivated our imagination. Its desolate landscape and thin atmosphere make it inhospitable to life as we know it. However, through the process of terraforming, we could potentially create a livable environment by altering the atmosphere composition, regulating temperature, and even introducing plant life to produce oxygen. There are various methods that scientists and visionaries have proposed to transform inhospitable alien worlds into habitable environments. Each method presents its own unique advantages and challenges. Let's explore some of these methods. One approach involves atmospheric manipulation. By altering the composition of an alien planet's atmosphere, we can strive to create conditions suitable for human habitation. This could involve introducing gases that promote the greenhouse effect, raising the temperature and facilitating the existence of liquid water. Conversely, we may need to remove toxic gases or regulate temperature to achieve a comfortable and sustainable environment for humans. Another method is geoengineering, where we manipulate the physical features of a planet to create habitable conditions. This could involve constructing artificial oceans or large-scale irrigation systems to distribute water across arid regions. Imagine using advanced robotics to sculpt the terrain, creating valleys and mountains, and designing ecosystems that support a diverse array of life. Biological approaches hold promise. Genetic modification to organisms to adapt to alien environments could enable the establishment of plant and animal life that can thrive in previously inhospitable conditions. However, this method raises significant ethical questions and concerns about the potential unintended consequences of introducing genetically modified organisms into alien ecosystems. Each method of terraforming presents its own set of advantages and challenges. Atmospheric manipulation allows for a relatively quick transformation, but it requires a deep understanding of complex atmospheric processes. Geoengineering offers the opportunity to sculpt landscapes and create suitable ecosystems, but it requires significant resources and advanced technological capabilities. Biological approaches leverage the power of genetics, but they necessitate careful consideration of ethical implications and potential ecological risks. But this is no simple feat. It requires significant scientific and technological advancements. We must unravel the mysteries of planetary systems, understand the complex interactions between atmospheres, geology, and ecosystems, and develop the means to manipulate them on a massive scale. Scientifically, terraforming poses immense challenges. Understanding the intricate systems of alien planets, their atmospheres, climates, and geologies is crucial for developing effective terraforming strategies. Simulating and predicting the long-term effects of our interventions requires sophisticated modeling and simulation techniques. We must unravel the mysteries of planetary processes and find innovative ways to manipulate them on a grand scale. Ethically, terraforming raises profound questions. As we alter the environments of alien worlds, we must consider the potential impact of existing ecosystems and any indigenous life that may exist. Preserving the integrity of these ecosystems and avoiding unintended ecological disruptions are paramount. We must strive to strike a balance between our aspirations for human habitation and the preservation of the natural order of these alien worlds. Logistically, terraforming presents formidable challenges. The resources, timeframes, and coordination required for such a monumental undertaking are immense. The international cooperation and collaboration among nations becomes essential as the magnitude of terraforming projects exceeds the capacity of any single entity. Allocating resources, sharing knowledge and expertise, and establishing a framework for responsible terraforming become crucial aspects of this collective endeavor. So, as we venture into the unknown, we must ask ourselves, are we ready to take on the challenges of terraforming? Can we unlock the secrets of transforming alien worlds and create new havens for humanity? But then again, the answers lie in our dedication to scientific progress, ethical considerations, and international collaboration. The Terraforming Timeline paper, authored by Aaron Berliner from the University of California, Berkeley, and Chris McKay from NASA Ames Research Center, outlines a timeline that includes a warming phase and oxygenation phase for terraforming Mars. The warming phase aims to raise the planet's average surface temperature and recreate a thick carbon dioxide atmosphere similar to Earth's. But before the terraforming process can begin, we will have to conduct pre-terraforming investigations. These include determining the water levels on Mars's surface, the amount of carbon dioxide in the atmosphere and polar ice caps, and the presence of nitrates in Martian soil. These factors play a vital role in assessing the feasibility of establishing a biosphere on Mars. Current evidence suggests that Mars possesses an abundance of the necessary elements for terraforming. Water exists mainly in the form of ice in the polar regions, but estimates indicate that it could support a water cycle, including clouds, rain, rivers, and lakes. Additionally, there is believed to be significant carbon dioxide and ice from the polar regions to create an atmosphere comparable to Earth's sea level pressure. Nitrogen, an essential component to a breathable atmosphere, is also present on Mars. Recent data from the Curiosity rover indicates that nitrates account for around 0.03% of Martian soil, which is encouraging for terraforming efforts. However, ethical considerations arise concerning potential Martian life and its impact on colonization efforts, particularly if it is related to life on Earth. The warming phase involves intentionally warming Mars by introducing super greenhouse gases into the atmosphere, akin to the unintentional alteration of Earth's climate. Mars could warm to Earth-like temperatures within approximately 100 years if solar energy is efficiently harnessed. However, they estimate that the efficiency of the greenhouse gas effect would likely be around 10%, prolonging the process to about 100 years. The subsequent oxygenation phase involves converting the Martian atmosphere into a breathable one. On Earth, high oxygen levels and low carbon dioxide levels are achieved through photosynthesis, converting water and carbon dioxide into biomass and oxygen. This phase could take between 100,000 and 170,000 years due to the likely lower efficiency of any process transforming water and carbon dioxide into biomass and oxygen. In our envisioned future, we imagine a multitude of habitable worlds, once inhospitable alien landscapes, transformed into thriving habitats for humanity. These transformed worlds become stepping stones, interconnected by a vast network of interplanetary travel and trade. A tapestry of diverse cultures, societies, and civilizations emerges, each contributing to the rich fabric of our expanded human experience. Terraforming opens endless opportunities for human colonization and resource utilization. As we establish permanent settlements on these alien worlds, we unlock the untapped potential of their resources, from rare minerals to renewable energy sources. These newfound resources drive scientific, technological, and economic advancements that benefit both the inhabitants of these alien worlds and humanity as a whole. But this future is intricately linked with the advancement of space exploration technologies. As we conquer the challenges of terraforming, our capabilities to explore and understand the cosmos expands exponentially. Improved propulsion systems, breakthroughs in sustainable life support systems, and innovations in space travel make it possible for us to embark on interstellar journeys, exploring distant star systems, and seeking new worlds to transform. Recognizing the shared destiny of humanity, nations come together, pooling resources, expertise, and knowledge to tackle the grand challenge of transforming alien worlds. International cooperation becomes a cornerstone of this mission, transcending geopolitical boundaries and fostering a sense of collective responsibility for the well-being of our species in the cosmos. As we gaze into the future, we are captivated by the beauty and wonder of terraformed alien landscapes. Lush green forests, cascading waterfalls, and vibrant cities dot the once desolate horizons of these terraformed worlds. We witness the resilience of life as it thrives in new environments, adapting and evolving to the challenges and opportunities presented by these alien terrains. As we reach the end of our journey through the world of terraforming, we are left with a sense of awe and wonder. This concept of transforming inhospitable alien worlds into habitable environments has ignited our imaginations and challenged our understandings of what is possible.